Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us move to the second paragraph of 2015 JEE Advanced Physics paper. Question number 39. Students, let us see the paragraph 2, that is the second paragraph, which says that in a thin rectangular metallic strip, a constant current I. So this is a strip, a rectangular strip, like a box structure, whose current I is flowing from this end to that end, as shown in figure. The length, width, and thickness. This is the length, this is the width, and this is the thickness. So this is the length, and this one is the width, and this is the thickness. Okay. Respectively, length, width, and thickness are given L, W, D. A uniform magnetic field B is allowed on the strip along positive y direction. So, which is in this diagram, you can see here, this is our x and this is our x and this is our y axis and this is our z axis. You can see here, you can look at this end. This is my x, this is my y, this is my z. Okay, so the length is measured along x-axis and along y-axis the thickness is measured, that is d. Along z-axis this is the width is measured. This is how this diagram is. Okay, so I just explained to you like this. This is like this, a slab is there, some thickness. So along this length, x-axis is there, and thickness is along y-axis, and the width, this one is along z-axis. So this is x, this is y, and this is z. So x, y, z, this is z, positive z-axis. So positive z-axis is along this direction. This is positive x-axis. So this one. So now the question is that the magnetic field is along y direction. So this direction the magnetic field is there. This is the magnetic field acting in y direction. So that is along the thickness. Due to this, the charge carriers experience a net deflection along z direction. Because we know that the formula of the force that the charge particle will gain when it is subjected to magnetic field is QVV. If I think of positive charge, then QB and B. Current is moving from this side to this side, from left to right. So QB is like that, and B is in y direction. So QVB. So this is the direction of the force. So this is moved to this side. This side means M side. So the charge particle, positive charge, will move towards this M side. So because of this, the M will be at higher potential and K will be at lower potential. The charge experiences a net deflection along the z direction. This results in the accumulation of charges. So this side it will be plus and this side it will be minus. Charge carriers on the surface of PQRS. This is PQRS. So this face and this face. This face is M and this face is K. So the charges will move toward this side and this will become positive and this will become negative. So there is an electric field that is established because of the accumulation of plus here and minus there. A potential difference along the z-axis is thus developed. So because of this accumulation charges, there is a potential difference. Here the potential is suppose Bm and here the potential is Vk. So the difference is Bm minus Bk, Bm having higher potential and Bk is at lower potential. Potential difference along z-axis is thus developed. So along this direction, potential difference developed, and charge accumulation continue. This accumulation of charge will continue until the magnetic force is balanced. Because of this magnetic force only the charges are moving. So charges are moving along this direction because of the force due to magnetic field is acting in this direction. If that force is balanced by the this electric or electrostatic force, this force due to this electric field developed because of the two sides of M and K. This is balanced by the electric force, because the electric force will also act in this direction. Suppose that electric force is Q into E and this magnetic force is QVB. This is the force due to electric field and this is the force due to magnetic field. When this is balanced, there is no further charge that will move towards this side. So in this situation, at equilibrium, this force will be equal, that is FB must balance with FE, or QVB is Q into E. This will balance. The current is assumed to be uniform distributed on the cross section of the strip and carried by the electrons. So these are the situations, and then QE, E in terms of this potential difference, if you want to write, then I can write BB equals to, then this is potential gradient, this is dm minus bk divided by the distance between this positive and negative plates or the sides. The distance is called that distance you divide here. That means this is this one and that one, and the distance here is w. W is the width, so therefore it is w. So after this, we have to see the question. This velocity is obviously the drift velocity, because this is the velocity with which the charge will move. So this is the drift velocity. This is the drift velocity, and therefore we have to see the questions for that. The question is, that consider two different metallic strips, 1 and 2. So we will consider two different metallic strips, 1 and 2, of same material. Their lengths are, so what is same? Material is same. Their lengths are the same, length also same. So like such plates, we'll consider two such plates, 1 and 2, something like that. Like this, you have got two such situations where what is same is material, same, length is same, L1 is L2, material, that is the specific resistance. I suppose that this is same, and the widths W1, W2 and thickness widths are different. This is W1 and this is W2, and its thickness is D1 and thickness is D2 respectively. 2 points K and M are symmetrically placed on the opposite sides, opposite faces parallel to XY plane. So this is the XY plane, vertical plane, and these two are symmetrically placed. So this is like this is the vertical plane, and on both sides symmetrically placed these two sides M and K. Now so plate and V1 and V2 are the potential difference between M and K in the strips 1 and 2. So Here the potential is given as this side it is V1 and this is given as V2. So potential on the two sides, the 2 points K and M are symmetrically located parallel to this. V1 and V2 are the potential difference between K and M in strips 1 and 2. So here the V1 is the potential difference, here V2 is the potential difference, this is potential difference. Between which 2 points? These 2 points, the potential difference between these 2 points, these two sides is V1 in the first case and V2 is in the second case. Okay, so this is the question, and what is you have to find is then for a given current I, so I is same, I1 is I2 flowing through the plate, given magnetic field B, the magnetic field is also same, that is B1 equals to B2. So these are the things which are different, all are same. Then which of the following options is or are correct? Okay, so we have to see the options which are correct. Then we'll check all the options, but before that we'll derive the expression. We have the expression that we got is BB is this one, that is BB, where V is the drift velocity and this is a potential difference across the two sides, that is given as M and K. So Vm minus Vk divided by the distance between those two sides, that is called W in the question. Now Vd is I divided by NEA, I divided by NEA, A is the area, and to B equals to Vm minus Vk divided by W, where A is the area of cross section of where A is the area of cross section of the conductor through which the current is flowing, and the current is flowing through this cross section area, which is having this is the depth and this is the width. So WD is the area of cross section. So I'll write here NEWD, B equals to Vm minus Vk divided by W. This difference is V1 and V2. In two cases we have two cases, 1 and 2. In one the potential is difference is V1, another is V2 are the potential differences between K and M. So between these two ends we have a potential difference. So this total, this one is V1, then we'll take V2. So we'll have I'll write this as V and we'll substitute 1 and 2 for the two cases. So this potential difference V by W comes out to be IB divided by NEW. So you can cancel W. So firstly we come to the conclusion that this expression is independent of W, independent of W. So in the second case, whether the width is same or different, that doesn't influence the relation because it is independent of W. This expression is independent of W. Now we have the relation that is coming out is V equals to IB divided by NED. This is the relation we are getting, and now we'll solve the question that we'll check the options. First option here, if W1 is W2 and D1 is 2D2, then this is this, correct or wrong, that would say. So what is the relation? W1 is W2 and D1 is 2D2, then V2 is 2V1. Whether this relation is correct or wrong. This condition will take the condition that is that they have same B will be same and the lengths are same. So what is same? Length and the B. So length and B will keep same in the expression that we have just derived, that B is IB divided by NED. D is the depth, and in this case what is same given in the question is B is same and the length is same, L is same. Again it is independent of L, so only B is same. If B is same, I is same, E is same, then V is inversely proportional to D. So here V is inversely proportional to D. If V is inversely proportional to D and independent of W, so this relation is always correct. And this relation means that if I, from here I can write D1 is 2D2, D1 is 2D2 implies D2 is D1 by 2. That means if this is half of the initial value, if this is a half, this will become double. That means if D2 is D1 by 2, that implies V should be, or V2 should be 2 times V1. So this relation is correct, because from this relation it is found that this relation is correct. So this relation is what? V1 D1 is V2 D2. This is a relation. So if I put D2 as D by 2 here, D1 by 2, then this D1 D1 cancel and this V1 will become V2 by 2. So V2 will be 2V1. That is correct relation. So option 1 is correct. So in this situation, this option 1 is correct. Then we'll check the option number 2. D1 is 2 D2. No, this is not right, because this already we have got. This is not right. We'll see the option number 3. If W1 is 2 W2, D1 is D2. If D1 is equal to D2, then V2 cannot be equal to this. This option is also not right. We'll check this option. This option, that option number 4. We'll see the option number 4, which is given as if W1 is 2 W2 and D1 is same as D2, then V2 is V1. As we can see the relation, if I don't make any change over here, there will not be any change over here. That means the V into D is same, product of these two is constant, and it is independent of W. So this relation, whatever is the relation here, if D1 is D2, if I put D2 as 2D1 here, D2 as D1 here, the D1 will cancel and V1 is V2. So from this relation you can see that B1 D1 is V2 D2. In place of D2 I'll write D1 here because given D1, so that will cancel out and V2 is B1. So this relation is correct. So the correct relations are 1 and 4. So these are the two correct relations. Okay, thank you.